Yes, let's look at question number 4. We'll be looking at volume and surface area. This comes in paper 2. Mr. Msondo is a farmer in Vumakala. He sells milk. The milk is stored in cylindrical or spherical containers that are sold to customers in 2 liters, 5 liters, 10 liters, 20 liters, and 25 liters. Pictures of the milk containers are shown below. This is a cylindrical and this is a spherical one. Sphere, it's like a ball. Cylindrical, it's like a tin, a can of Coke, a tin of baked beans, the cylinder. Now, so this height here is for the cylinder, the radius is for the sphere. All right, let's continue. These are the formulas given to you, and you may use them, or you might need to use them. Use the information above to answer the questions that follow. They are saying convert the 770 millimeters to meters. So here we are converting millimeters to meters. Remember, we have this. So it's accommodated here. 1, between kilometer and a meter we have 1,000. Between a meter and a centimeter we have 100, and between centimeter and millimeter we have a 10. So simply meaning we need to change the millimeter to centimeter, then we change it to meters. But when you look at it critically, you have tampered with approximately 1,000. When you look at it, it's 1,000. So what you're going to do, remember we said small to big, we need to divide, whereas big to small, we need to multiply. So we are from small to big, we're going to divide. Millimeters to centimeters to meters, we need to divide by 1,000. So we shall get the 770 divided by 1,000. The answer becomes 0.77 meters. All right. Determine the diameter of a spherical. Determine the diameter of a spherical milk container. As I showed you up here, the radius is for sphere and the height is for the cylinder. So remember, when we are looking for the diameter will equal to 2 times radius, which is the same as 2 times 2 times 73.5, and gives you the answer as 147 centimeters. 100. So define the term capacity. Capacity goes hand in hand with the volume, but capacity, we shall say, is the total amount of quantity a given container can carry or contain. You understand? Total amount of quantity a given container can hold or carry. If not, you might say in this context now, it will be this contest now, it's going to be capacity is the amount of milk these containers can carry. Amount of the amount of the amount of the amount of milk these containers can carry. All right. That is it. Now they ask for volume. Actually, capacity in most cases it will be in the normal form of liters, milliliters. We take example of your geyser at home. Its capacity is measured in liters. But when we are performing or when we are calculating this capacity, we need to have volume. So it's from volume that we get capacity. Volume is the normal one, the calculations in centimeters cubed. You understand? The space a given object takes. All right, here we go. Calculate the volume in centimeters cubed of the spherical container. What we are going to do, we go back to our formulas here. What are we looking for? Volume of a sphere. So here we are. We are going to use this one, which says 4 times pi times r cubed, volume. So we write volume equals to 3,142. They told us times 4 times r cubed. All right, this is for a sphere. But we already know that the radius is already given, so it will be 4 times 3,142 times the radius that we already know as 73,5. It has to be cubed. What answer do you end up having? Let me do it here on my calculator. Have the answers. For 1,990,317,63 centimeters cubed. Centimeters cubed. Then we come to this. They say the capacity of the cylindrical container, is 60 liters. Determine the diameter of the container. Round off your answer to the nearest centimeter. Now, we need to ask ourselves, well and good, they have capacity. And I told you its capacity comes from volume. So what we need to do is to know, change this capacity that we have, we change it back to volume. In this sense, because now they have told us centimeters. So it means we are going to change the liters. Change the liters to centimeters. You understand? Change the liters to centimeters. Then from here, 1 liter equals to 1,000 centimeters cubed. What about if you have 60 liters? What will it be? One liter equals to 1,000 centimeters what? Cube. So if you have 60 liters, what will it be? Multiply by 1,000. So you have 60,000 centimeters cubed. This is now our volume in the normal sense of. I'm using centimeters cubed because I need my answer to become centimeters. I keep it aside. Then I ask myself, okay, if this is the volume, how did they get it? Remember, we are looking for the volume of a cylindrical container. In our heads, we know that already. Volume of a cylindrical container equals to pi r squared h. Do I have the volume? Yes, it's 60,000 centimeters cubed equals the pi is a normal number that we know. Times, what are we looking for? We are looking for the diameter. Do we have the diameter of the cylindrical container? No. So the reason why I'm looking for the diameter. So the reason why we are looking for the diameter, it's actually it's the question. So we don't have the radius. Right? It was not given. So we leave it as square radius. What? Square times. We have the height. Remember with the height we said it's the height is 770 milliliters. Change it to the height. Let's change it to centimeters. It becomes divide by 10. You end up having 77 centimeters. This is the height. So I bring it here. So what I do, I take the normal number. 3,142 times 77 equals to 241,934. I will leave it like this. Times r squared should give us 60,000. I divide through by the same number on both sides. I divide through by the same number on both sides. It will die. Yeah, it will die. So I'm remaining with radius squared equals to, when I divide this other 60,000, I'll end up having, when I divide by 60,000, when I divide 60,000 by this number, I end up having 248,0015211. So on your calculator, because it's squared, I need to know what is r only. So it's because squared, I need to look for the square root on both sides. So I'll find the square root. So find the square root of the answer there. I end up having 15,74806.04. Now our radius is this much. I need to multiply by 2 because I'm looking for the diameter. So my diameter will become 31,96, which is approximate, because they said to the nearest centimeter. So we don't need the commas. So which is approximately 31 centimeter. When you look at this is 8 marks, and you ask yourself, how was it marked? Let's try to mark it and we see. Did you change the liters to centimeters cubed? Wonderful. Did you change from millimeters, the height? Did you change from millimeters to centimeters? Another mark. Did you understand this concept? One mark for that. Understanding this concept. Dividing, another mark. You applying the square root, 1 mark. Getting the right answer, 1 mark. Multiplying by 2, 1 mark. The final mark is here. Take note, whenever something is missing, whenever there's something that you find, you need to find, you need to show it, please. Right? For example, here you knew liters have to become centimeters cubed. That's a mark. You knew that the height is in millimeters, it has to become centimeters. That's another mark. You understand? That's a mark. Then you substituting to get the formula, knowing what is there. You know, you would get a mark for that. All right, that's how it was marked. Let's go to the second question. Next question. 4.1.6. Determine the number of 1.5 liter containers that would be filled with the milk from the cylindrical tank or cylindrical container. Remember, the cylindrical container is worth 60 liters. Someone wants, it comes with 1.15 liter containers. How many shall we get from there? It becomes 60 divided by 1.5. You have 41.5 liter what? 1.5 liter what? Containers. Okay, we look at this diagram 4.2. Let's look at it critically and we shall be. All right, this is a rectangular prism, of which we know. Within what comes in your head when the moment you say a rectangular prism, if they ask for volume, volume will always be. And if they ask for surface area, when it's closed, it will be 2 into L times B plus B times H plus L times what? H. If it's closed, but if it's open, it would depend on which side is open. It would depend on which side is open, then you have to manipulate it. All right? These are the formulas that I know I should remember when I look at a rectangular prism. All right. Mtondo makes a rectangular water troughs for his farm animals using concrete that is 5 centimeters thick. The diagram below shows the external dimensions of the rectangular trough with an open top. You see? So it's open. So this one here, if you're to look for the surface area, it simply means this side is closed. So it will be, let's say this is B, this is the height, and this is the length. So if this side is closed, so it will be B times the height, but these sides are 2 then. So we shall multiply by 2 plus this side equals to the, so they are also closed. So it means it's 2 into L times what? Height. Plus this side, the bottom is closed, but the top is not there. So simply meaning it will be L times what? B. That's if they ask you for surface area of an open one. Why? The part here, it's missing, it's not there. Anyway, now we go on and you see these are the dimensions that we have. They are saying, wow, calculate the internal, use the diagram and the information to answer the questions that follow. The external dimensions are the external dimensions of the, so in most cases when we look at this, definitely this has to be the length, right? And the height. In most cases when you see it like, oh, sometimes they will write it like, they will put the times sign. The times sign means by. If it's given this order, you also understand it's this other form here. But these are external, outer dimensions. So, calculate the internal dimensions of the trough in centimeters. Now, how are we going to get the internal? Remember, the dimension from outside, from here to there, it won't be the same as you measure from inside here to there. Why? There's a thickness. There's a wall that already has 5 centimeters. So if the dimensions are 5 centimeters thick, that means you're going to subtract 10 on both sides. You understand? For the length, you're going to subtract 10 because we have the 5 this side and the 5 that side. The breadth is same story. You need to subtract the 10 here, 5 that side, 5 this side. The height, you only need to subtract 5. The bottom part is represented because the top one is nothing much. There's nothing here. All right, let's go and see. So we say the length will be 300 minus the 5 centimeter on one side minus another 5 centimeter, which will be 290. We go to the breadth, which is 190 centimeters. Also, you subtract 5 on one side, another 5 on the other side. So you remain with 180. Don't forget these are centimeters. In the height, we said we shall only subtract 5. Why? Because the other side on top it's not covered. So it becomes 155. Don't forget these are centimeters. Don't forget that. All right. Hence, hence show by calculations that the internal volume capacity of the trough is 8,091,000 centimeters cubed. So they have given the formula here already. You remember we are looking for internal volume. So you come here, you will say what's my new length? It's the breadth is 180 times 155. Did. That is the answer. We are using, they are saying hence. So simply meaning you're supposed to use the values that you find here. These are the values that we are supposed to use. These are the values you are supposed to use. Given that 1 gallon of paint covers approximately 280,000 centimeters squared, Mr. Nsondo claimed that 3 liters of paint will be enough to paint the internal surface area of the trough. Verify using calculations of if his claim is correct. You may use the formula. They said you may use the formula, but when you look at the formula critically, it does not cater for what we said. It does not cater for an open. It does not cater for an open rectangular prism. So we said, yeah, this one here, it's supposed to be 1, not 2. Why? One side is open. There are not 2 sides. So we only need to look for the area of only one side, which is the bottom. So if you having removed the 2 here, then these other ones are okay. So we start inserting. Remember they said internal surface area. That means we're using the internal measurements that we got. Together, the length, we've got it as 290. The breadth, we've got it as 180. And the height, we've got it as 155. These are centimeters. So these are the values that we got in the first place, which was these were the internal values. So now we come and we substitute them into where we see the L, we put the value. Remember, we removed this because it's an open area. It has an open end. So we shall say plus 2 into L, our length to 90, times the height, which is 55, plus I'm adding because this 2 here is the same as this. I've put it out. So which will become the breadth times. So that will become 290 times 180. 290 times 180 equals to 72 into It's 52,200 plus 146,170. So the total area that we need to cover here is supposed to be 198,300. What? So this is not rand, sorry. Centimeters what? Squared. So that is the area to be, the internal area to be covered, to be painted. To be painted. Now, we are not proving the area to be painted, but we need the paint to be used. So we need to know the area to be painted. This is what we are doing. All right, this is supposed to be the answer. When you multiply this very well, you have to get the answer as that much. Mm. Yeah. So this is the answer. This is the area to be painted, but we are not interested in the area. We are interested to prove that the 3 liters will be enough for the paint. Now we shall ask ourselves, look, the spread rate is given in gallons. You understand? 1 gallon. 1 gallon covers an area of 280,000. So for us, we have an area of 197,900. So what is it going to be? So we shall do that and we cross multiply and we find out the answer, which is we divide it by that much. So in divide, when you divide, you end up having 0.076. These are gallons. So change them to liters because her claim is 3 liters. So if 1 gallon equals to this much liters, what about this gallon? So we shall multiply by 3, 3,785. So the answer is 2,75 liters. Remember, they don't buy in half liters. So approximately what? 3 liters. So the claim is valid. The claim is valid. One, we had to look for the area. You looked for the area. Having looked for the area, you had to look for how much paint do you need? How much paint? This is what you got. You got it in gallons. You changed it in you changed the gallon, and you got your answer there. You verified the claim. 1, 2, 3, 4, 5, 6. Yeah. 8 what? 8. Look for the area. This is the area to be covered. This is the area to be covered. You get the area, you divide it by the spread rate, looking for the number of amount of paint. The amount of paint is in gallons. You've changed it to liters. You've got the answer, which is approximately. Then you concluded. You verified. That's how we get 7 to 8 marks. 7 to 8 marks. All right, someone will look at this. I have substituted for letter by letter 2, L, L, H, 2, W, W, H, H. And I got my answer as this. I put everything into the calculator. So I've looked for the area. And good, I have now the area to be painted. Now, I come on and I look for what we call the the spread rate. What we call the spread rate. The spread rate is 1 gallon. 1 gallon equals 1 gallon covers an area of 280,000 centimeters squared. I have an area of 197,900 centimeters squared. So how much paint do I need? So what I said, 1 gallon, but 1 gallon is the same as 3,785 liters. So I said, okay, that means that if I have 3,785 liters, I can cover an area of 280,000 centimeters squared. But now I have 197,900 centimeters squared. How much do I need to cover this much? So I came here, I did this, I cross multiplied the box multiplied with this. That's why I have this. Then this number here multiplied with this. That's why I have this now on top. Because I'm looking for this box here. I'm looking for this box. I'm looking for the answer in this box here. What do? I needed to divide by on both sides. In that I remained with the box on side. When I divided this, I ended up having 2,675 liters, which is approximately 3 liters. 3 liters, and I did need to conclude, which becomes valid. Why am I saying valid? Because the claim, it says 3 liters will be enough. You understand? Yes, indeed. We need 2,67, which is enough. So 3 liters are enough. So the conclusion is what? Valid. So we have area, well and good. We've divided to look for the number of liters, well and good, from gallons. I multiplied that 1, 2, 3. I get this. I concluded as this. So my verification. So 1, 2, 3, 4, 5, 6, 7 could be your substitution here again. So 1, 2, 3, 4, 5, 6, and what? 7.